Why isn't the store opening for me? Bill Nye here, and that is because of inertia. An object at rest tends to stay at rest unless acted on by an outside force.
Whoa, thanks, Bill Nye.
Go right in. Just remember,
Inertia is a property of matter.
Bill,
T minus 7 seconds.
Bill Nye the Science Guy.
Please, consider the following.
consider this ball. If I were to throw this ball and there were no outside forces, it would continue to go on and on forever. But if it were acted on by an outside force, such as Henry catching it, it stops. Why is that? Inertia. Inertia is Newton's first law of motion. An object in motion stays in motion, and an object at rest stays in rest, unless acted on by an outside force. One common misconception is that this ball, when thrown in space, it will actually continue on forever. People don't think this because on Earth, we have outside forces such as gravity, friction, air resistance, and other things that act upon it and make it stop, like this. See how it stopped? Well, that's because these outside forces acted upon it. If it were in space, that would not be the case. Consider this. Now back to your show. Nope, not gonna work. Nope, not gonna work. Nope, not gonna work.
Why?
Because force equals mass times acceleration. The acceleration will be the same on both due to gravity, but the mass is different. So the force will be different on there and it will trigger the booby trap.
Screw all the science.
Yep.
I told you, Andy, that wouldn't work. John Green here, with Crash Course Physics. I usually stick with history, but today I'm doing this show, just for you. Today I'm going to talk to you about Newton's second law. Force equals mass times acceleration. Now to do this, I'm going to use golf clubs. This is a 3 wood. This is a 3 iron. Same type of club, but it's a different kind. So, which one will hit the ball farther? This one, the wood, because it has more mass. Now, one common misconception is that an object that's small can't have the same amount of force as an object that's big. But, take a bullet for example. Not this bullet because it's made of foam, but an actual bullet. If I punch someone, it'll have less force than a bullet shooting at someone because of the acceleration. Thank you for joining this week's episode of Crash Course Physics. Join us next week when we talk about the legend of Harambe.
What? Why doesn't he move?
Hi, Jamie Hyneman here. You see, Indiana, when the bullet bounced off of him, it had less mass and more acceleration. However, he had more mass and less acceleration. So, the bad guy didn't budge because the forces were equal. Why did you just shoot me at him?
Oh, it's for our next myth about recoil. When you fire a gun, your hand moves back. Now, why is that?
Some people think it's the magic of firearms, but we have a different theory. Now remember, kids, don't try any of this at home.
We're professionals. Today we're at our bomb range to test and see our hypothesis about these guns and their recoil. Wow, good recoil.
Now we're going to head back to our lab to further calculate and test our hypothesis. Adam. Now, while Adam is still picking up the carnage of what we left behind at the range, I'm here at the lab doing the real work. We know that the mass of these bullets is about 4 grams, and we're about to test the acceleration when fired from the gun. We've rigged up this contraption to also calculate the force of the recoil when the gun is fired. Now, according to our hypothesis, the mass of the bullet, 4 grams, times its acceleration when fired, should equal the force of the recoil. Let's test it out. Well, I just finished doing the calculations of the forces for that last experiment we just did.
Hey guys, I'm back from the range.
Anyway, it looks like the force of that recoil did indeed equal the bullet's mass times its acceleration.
Guess it seems our myth is busted. Now back to you, Indiana.